My name is Megan Aranganathan, and I am a mathematics major at Swarthmore College. I am applying to NYU's program in Atmosphere, Ocean Science, and Mathematics, and here I'm going to talk to you a little bit about my interest in math and why I'm applying to this program. I really enjoy studying complex systems and randomness. Mathematics has a fascinating ability to show us aspects of our world that we would never imagine ourselves, and I think it's a testament to the power of mathematics that we can learn about future behavior of systems and apply it to our knowledge of the world. I first started thinking about this during a probability class. For an example, say you're asked for a randomly generated sequence of 100 zeros and ones. A human would produce a pattern that looks something like this, because this is what we think of as random. However, a truly random sequence of 100 zeros and ones will almost always contain a consecutive sequence of 6 identical numbers, such as here, a consecutive sequence of 6 zeros. The human brain naturally just has a difficulty understanding and comprehending randomness, and mathematics for me was almost a microscope into this random complex world we live in, where suddenly I could analyze and predict probabilistic events far more accurately. I then took a stochastic modeling class where I could apply this understanding of probabilistic events to figure out what might happen in the future. As an example, we can talk about random walks. The most common, simplistic problem is the drunkard's walk, which considers the case of a drunk person stumbling with equal probability in each direction in some dimension d. The question is, will she get home eventually given infinite time? And it can be proven using Markov theory that she will in fact get home in cases of dimension less than or equal to 2, but she will remain forever lost in dimensions 3 and above, which is both good news for our stick figure as well as an interesting probabilistic result. And then we consider the progression of larger scale systems through time using deterministic systems, which often tend to a certain steady state, which is a state in which the behavior of a system stops changing in time, which occurs, in this case, here and here. But of course, this steady state is on a hill and therefore likely to roll in one direction or the other. So we have this intermediate ball that shows this steady state tending toward stable steady state, which is represented here at the bottom of the hill. Thus, using the systems analysis, we can actually theoretically analyze the behavior of a given system. I particularly love thinking about these areas of mathematics because it's often unpredictable, unintuitive, but it illustrates a part of our world we often don't think about, which is where does complexity, randomness, and chaos factor into our world, and how do we harness it in models to understand future behavior? This brings me to my future career goals, which is hopefully studying climate dynamics. The ocean-atmosphere system is a complex system which involves the study of nonlinear dynamics, chaos, and an incorporation of randomness, which fundamentally is just really cool. We have interactions between ice, clouds, the ocean, and the atmosphere, and I hope to study what factors affect climate variability, especially in short-term weather. I want to know how we can better understand all of these nonlinear dynamics to forecast weather and climate. And I'm particularly passionate about understanding the system because it's both interesting as a mathematical system in which we can learn more about theoretical nonlinear dynamics, dynamical systems, and their behavior, but it's also interesting as a socio-political issue that affects people across the world. And this brings me to my final point, that my ultimate goal for a PhD is to be able to explore complex nonlinear systems with a particular emphasis in climate dynamics. NYU's Atmosphere, Ocean Science, and Mathematics program would be ideal for me because it would let me establish that solid applied mathematics foundation while also getting to do research in and apply that information to climate dynamics. This program would let me pursue both my interests simultaneously, and I'm really excited for that opportunity. Thank you so much for listening.